Okay, lab 7, we're going to generate a gas. We're going to make some hydrogen gas, and we're going to try to experimentally determine the molar volume of a gas. Now, from chapter 7, we know that at STP, which the laboratory is not at STP, but if we were at STP, which by the way is 1 atmosphere and 0 degrees Celsius, the molar volume of a gas is 22.4 liters. So that means if you have a mole of gas, it should occupy this space. The laboratory in Late Night Labs is actually 21 degrees Celsius, and if you read the background, we know that we're at a higher temperature, and at this higher temperature the expected molar volume is 24.137 liters per mole. I think this information is given in the background. So what we're going to do in the experiment is drop a piece of zinc. We will know how much to use because we're told an exact amount to use in the procedure. So we'll know how much zinc we're using. We're going to drop it into some hydrochloric acid, and we're going to make some hydrogen gas. So just a couple things to notice here, because we are going to be looking at the moles. In this balanced equation, which is now balanced, the mole ratio between zinc and hydrogen is 1 to 1. So if we know how much zinc we're using, we should be able to predict how much hydrogen we've made with relationship to moles. So what we're going to do is calculate an experimental molar volume and then compare it to what we should get maybe in theory at 21 degrees Celsius. The data that you're collecting is a limited amount of data. You're going to know the mass of zinc. In fact, you're going to be told how much to use exactly. And you're basically just going to make the hydrogen in a container and collect it in a gas piston, and then you'll know the exact volume of the hydrogen. So you're going to record these in your lab. I think this is recorded as part F. And then as we proceed through the calculations, what we would really like to know is how many moles of zinc we've used. So we'll do a straight gram to mole conversion. So we need the molar mass of zinc, and we can convert grams to moles. Now again, this is going to be a decimal value because we're not doing a huge amount of zinc. We're doing the reaction on a small scale. So as has happened in the last couple labs, your mole value will be small, and you probably want to keep several digits here and don't round at this point. Probably the most common mistake students make is in part, let me see, I think you're going to find in part D this value. And then part E, the question is, well, how much hydrogen did you make? Well, if we go back and look at the balanced equation, the number of moles of zinc compared to the number of moles of hydrogen, this is a 1 to 1 ratio. So moles of zinc should be equated to moles of hydrogen. So once you've calculated the value in D, it is the same as moles of hydrogen that you'll report in part E. So we're able to do this because the reaction is 1 to 1. Now the only thing we need to do with this milliliters of hydrogen, because we normally express molar volume in liters, is we just need to convert milliliters to liters. Okay, so that's just a straight metric conversion, and that'll get us liters of hydrogen. This is necessary to carry out the next calculation. The next calculation is the one we're interested in, and it is molar volume. So we want to express how much space does a mole of, in this case, hydrogen occupy. And you're going to actually record this in part G, but Now keep in mind, this is the whole goal of the lab, so you want to make sure your calculation in G is correct. You're going to take the liters of hydrogen that you converted and divide it by the moles of hydrogen in part E, which is, of course, the same as the moles of zinc in part D. So your answer here will have units of liters per mole. And that's really the point here of the lab, is to experimentally calculate that. Question 2 goes on one step further and asks you to compare it, your value, this is your experimental value, and you want to ask, how does it compare with the theoretical value of 24.137? So you're asked, and you have a formula there to then compare your answer with the 24.137 theoretical value. And then multiply by 100, and then you should be able to get a percent. And I'll just let you know that in the perfect world of late night labs, this should be very low. So there's not a lot of error in this lab.